Okay, another video of solving algebraic substitution in integral calculus. In this case, we have the example of the integral of dx over the square root of x plus the cube root of x. So since, we all know that the square root is equal to, 1 over 2. And on the other hand, cube root of x must be simply equal to x raised to 1/3. Okay, what I did here is that I took the LCD or the least common denominator from the denominator in this example. Since we have the square root of x that equal to x raised to 1/2, and for the other one is x raised to 1/3. So what I did is I separated and get their LCD or the least common denominator. But how do you do that? Well, simply get the denominator, which is 2 and 3, and divide it by itself until you get the least common denominator, or the least number that, similar to each term. So here we have 2, 4, 6, and so on. We have 3, 6, 9, and so on. Now, the least number that similar is 6, right? Therefore, the LCD of x raised to 1/2 and x raised to 1/3 is x raised to 1 over 6. So that is the, no, that is the new equation from the original. But there is, you know, denominator that must have its own property. So from the new equation, we have dx over x raised by 1 over 6. So we let z, or any number, whatever the number you prefer. So yeah, so I would prefer z as my variable or my u. So I let z as the denominator, which is x raised to 1 over 6. And then I would neutralize it by multiplying the reciprocal of what x is raised. So that would be 6, since the reciprocal of 1 over 6 is 6. And then distribution um, property. So distribute this n to each term. So we have 6, z raised to 6. And this would be cancel. And that would be x. Since we do have x and we don't have a dx or the terms that we can substitute to the original equation, so we have to derive it or to differentiate the x. So this would be equal to 6 z raised to 6 minus 1, that would be 5, and the derivative of x is simply dx. Oh, I forgot this. Okay, since we do have dx, is we are not done yet, to substitute all the value that we get. We do have x and dx, but we got no terms or a certain values for the square root of x and the cube root of x. And that is why we get its LCD. And to get the LCD, we gotta have, x raised to 1 over 6. And we gotta be using that to find its value. Okay, from this, I will use z is equal to x raised to 1 over 6, since that is our LCD. And I would, multiply this into 2 or 3 since that is the closest number from here and to the cube root of x. So I will multiply both sides by 2. That would be equal to z raised to 2 is equal to x. So this should be 1/3. And for the other one, I will use this again and multiply it with different number. So I will multiply it by 3. So this now equal to z raised to 3 and x raised to 1/2. Now I got the value of the square root of x and the cube root of x, which is z2 and z3. And now I can substitute all the values that I got from here. So we do have dx, we have x, we have this, and we have x raised to 1/2. Okay, substituting all the terms from the original equation, this should be equal to this, to the integral of dx, which is 6z raised to 5 dz all over the square root of x, which is this, so z raised to 3 plus the cube root of x, which is z raised to 2. And now, as you have noticed that the denominator could be cancelled, could be factored. So basically 6z5 dz. So this could be factored. So z, this is z raised to 2 plus 1. So this can be cancelled and matitira yung 3 and this could be cancelled. And now the new equation would be equal to z, 6z raised to 3 dz over z plus 1. And now since we do have a constant inside, so I could bring it to the outside equation. So this would be equal to z3 dz all over z plus 1. And now since I do have, such equation like this, is I'm going to perform a long division or synthetic division. So dividing further, I could have 6 integral of z raised to 2 minus z plus 1 minus 1 over z plus 1 and then dz. Okay, so we can now perform basic integral rules. So we have 6 and this should be z. So 2 plus 1, that would be 3. And also to the denominator, we have 3 minus z raised to 2 over 2 plus, this is simply z na lang, minus, this is the ln, the integral of d over u, which is equal to ln plus c, or ln absolute value of u plus c. So this could be equal to minus ln z plus 1 and then plus c. And now since we can simplify this, so 6 divided by 3, that would be z na lang raised by 3. Tapos, this could be 2 na lang. Minus 6 and 2. That would be equal to minus z raised to 2 over 3 plus z minus ln of z plus 1 and then plus c. Now, simplifying this further, we have, since meron 2 dito, I forgot. So this is, we do have 3. So 2, what is our z? 6. So since we have the value of z, which is equal to x 1 over 6. So this would be x 1 over 6 and then the cube. And this is minus 3. And then we have the value of z, which is x raised to 6, and this would be equal to x 1 over 6 over 2 plus z. So since we do have 6 here, from here, I can distribute it to the z and to the ln. So this would be equal to 6 and then x, or x 1 over 6, this is the z, minus, but minus 6 ln. So we have the value of z, which is x raised to 1 over 6 plus 1 plus c. So simplifying this, we have 2. So distribute that into 3 from inside function. That would be equal to the square root of x minus 3. This is cube root of x plus 6. And then this is simply 6 and then x minus 6 ln of x square of x and then 6 plus 1 and then plus c. And that would be the final answer.